Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Chemistry class, Chapter 5, Liquids. Today, topic under discussion is vapor pressure. We will define it, explain the definition, then we will explain intensive property of liquid, unit of vapor pressure, affecting vapor pressure, measurement of vapor pressure, and at the last, there are few questions for you people. Let us start our lecture. What is vapor pressure? Vapor pressure is basically the pressure exerted by the vapors in thermodynamic equilibrium with its condensed phase. Condensed phase is liquid or solid at a given temperature in a closed container in a closed system is known as vapor pressure. This definition is explained by an example in the next slide. Vapor pressure is nothing but the tendency of particles to escape from the liquid surface. At normal temperatures, substance with high vapor pressure is often referred to as volatile liquids. Let us explain the definition. Here we have a closed container in which liquid is filled. These red circles are showing liquid particles. At room temperature, at all room temperatures, liquids have the ability to evaporate. These molecules from the liquid container and from the liquid surface got evaporated and come on top of the liquid surface like this. In the next phase, this is called evaporation. When liquid molecules are converted into the gas or vapors, this phase is called evaporation. This evaporation continues and the rate of evaporation at the start is slow, and as we proceed towards the end, rate of evaporation is high. At times come when the molecules that have been evaporated and now are in vapor phase are in very high number. Now these molecules collide with each other and some molecules lost their energy and are dropped into the liquid surface. And now they are converted into liquids. That is, molecules from the gas are converted into liquid. This process in which vapors are converted to liquid is called condensation. These purple molecules are showing condensation. You people can see very clearly that rate of evaporation is higher than rate of condensation at start. After some time, you see that there is no apparent change on the liquid surface. This is because the molecules which are converted from liquid to gas is exactly equal to the molecules which are changing their phase from vapors to liquid. That is, evaporation is exactly to the condensation. Rate of evaporation is exactly equal to rate of condensation. At this phase, the number of molecules from the liquid surface entering into the gas surface is exactly equal to the gas molecules which are leaving the gas phase and entering into the liquid form. Now, these vapors, now this is a stage of dynamic equilibrium in which rate of evaporation is equal to the rate of condensation. At this state of dynamic equilibrium, these vapors exert a pressure on the top of its molecule, on the top of its liquid surface. This pressure is called vapor pressure. Now we can define it as the pressure of the vapor present at equilibrium in a closed container is called vapor pressure of the liquid. These vapors are exerting pressure which is known as the vapor pressure. At equilibrium, rate of evaporation is exactly equal to the rate of condensation. That is, liquid converting into the gas is exactly equal to the gas molecules which are converting into the liquid. Vapor pressure is an intensive property. What is intensive property? The properties which are independent of the amount of mass is called intensive property, like temperature, vapor pressure, and density. Extensive properties are the properties which varies directly with the mass, like mass, volume, energy, and enthalpy. Vapor pressure is intensive property of a liquid. Now come towards vapor pressure unit. Unit of vapor pressure are Pascal, and 1 Pascal is 1 Newton per square meter, that is n meter minus 2 or kg meter inverse second inverse with 2. Factors affecting vapor pressure are temperature and forces of attraction. First of all, we will discuss how force of attraction affect the vapor pressure. They are in a inverse relation with each other. For example, molecules like water, which have strong forces of attraction, have low vapor pressure. Why? Because molecules are tightly bonded with each other and they cannot evaporate, they cannot convert it into vapors at room temperature. Less molecules are converted into the vapor, so their vapor pressure will be low. And these molecules are regarded as non-volatile. Vice versa is the situation. When forces of attraction among the molecules are low, they can easily evaporate. That is, number of vapors increases, and as a result, vapor pressure also increases. And these molecules or these liquids are called volatile liquids, like ether, which is volatile because it has weak forces of attraction among their molecules. Here we consider a graph between three liquids, diethyl ether, ethyl alcohol, and water. The graph is plotted between pressure, which is in mm of mercury, and temperature at which is plotted in degrees centigrade. At this, you can see this line is at 760 millimeter of mercury, which shows the external pressure. When vapor pressure of all these liquids becomes equal to the external pressure, that is 760 millimeter of mercury, these liquids starts boil. Now we will see that diethyl ether boils at 34.6 degrees centigrade. Ethyl alcohol boils at 78.3 or 4 degrees centigrade, and water boils at 100 degrees centigrade. Why these liquids have different boiling points? It is related to the forces of attraction. As water has strong hydrogen bonding, so it has high vapor pressure. And at 100 degrees centigrade, its vapor pressure becomes equal to external pressure, that is 760 millimeter of mercury, and it starts to boil. Ethyl alcohols have weak hydrogen bonding as compared to water, so it boils at 78.4. Diethyl ethers have weak London dispersion forces, weak forces of attraction, so it boils at 34.6 degrees centigrade. Next is temperature. As we know that temperature is basically kinetic energy, is directly proportional to the kinetic energies of the molecule. When temperature is increased, kinetic energy of the molecules is increased. Vapor pressure is in direct relation with the temperature. How? When we increase the temperature, vapor pressure will increase. When we decrease the pressure, vapor pressure will decrease. How? Basically, when temperature is increased, average kinetic energies of the molecules increases. These kinetic energies can easily overcome forces of attractions. Now they can escape out as vapor, that is increase the rate of evaporation and condensation, means that they have increased vapor pressure. You can see it here in the diagram. When temperature is low, these molecules are showing vapor pressure, it is low, and when temperature is increased, vapor pressure is also increased. Vapor pressure increases with increasing temperature. Like at 20 degrees centigrade, vapor pressure will be low, as you can see from the diagram. When temperature is increased up to 80 degrees centigrade, number of vapors above the liquid surface increase, which directly increases the vapor pressure. It is because increase in temperature increases the kinetic energies of the molecules. So these molecules can easily overcome intermolecular forces of attraction and easily change their phase from liquid to gas. Again, we consider the same graph between diethyl ether, ethyl alcohol, and water molecules. Graph is plotted between pressure at millimeter of mercury and temperature at degree centigrade. Vapor pressure of water at 0 degrees centigrade is 4.6, and at 100 degrees centigrade, vapor pressure is 760 millimeter of mercury. It means when temperature is decreased, vapor pressure is decreased. When temperature is increased, vapor pressure of water will be increased. How this pressure affects boiling point of liquid? Boiling point changes with change of vapor pressure or external pressure. Less pressure, water in case of less vapor pressure or less pressure, less external pressure, water boils or liquid boils at low point. Like water boils at low temperature at high elevations, like Mount Everest, liquid boils at 76 degrees centigrade. When external pressure is high, water boils at higher temperature. For example, at pressure cookers, in which external pressure is high, so water boils above 100 degrees centigrade. Next is how to measure vapor pressure. There are two methods to measure vapor pressure: barometric method and manometric method. This is barometric method and this is manometric method. This is end of our topic. Now come towards assignment. Here are few questions for you. Justify the following vapor pressure order among liquids. Diethyl ether have high vapor pressure than ethanol, and ethanol have high vapor pressure than water. Water boils at 100 degrees centigrade while ether boils at 35 degrees centigrade. Put your comments. Liquid possesses intensive property. Explain the statement. Define vapor pressure and give its unit. Petrol have high vapor pressure than water, but I hope you have enjoyed the lecture. Thank you and have a nice day.